So let us see unit number 6. So in this video, so I am going to explain you. So unit number 6, that is optimum design. Okay. So first of all, let us see what is meaning of design. So design means already we have studied in the DMU. You studied in the DMU 1, DMU 2. So design means it is to find the dimensions of the part or a product to meet the functional requirement. Suppose if you take example of shaft design. So shaft design means it is to find the size of the shaft to meet the requirement. Requirement means power transmitting capacity or torque transmitting capacity. So that is the design. So optimum design means, so let us say example, I want to design the shaft, but in front of me there are 5 number of materials available, so by which I can design the shaft. So out of that, which one I need to select? Which material I need to select to make it more economic, more suitable design? So that is, suppose if I want to design the shaft with minimum cost, then we have to select such material, so which will leads to the minimum cost design. So that here parameter is optimizing parameter is cost. Sometimes if you want to design the shaft for minimum weight, then we have to select such material, so which will leads to the minimum weight of the shaft. Means here not just we are designing with by optimizing the required parameters like cost and weight. Okay, so this is difference between just design and optimum design. Design will have many solutions, but optimum design will have only one solutions. So to make the optimization, so we are going to consider certain parameters, so which are called the design parameters. First one is functional requirement parameters. So for any design solutions, so there will be a functional requirement. Suppose if you take example of the shaft, if I want to design the shaft to transmit the particular amount of power, so here power transmitting capacity is the functional requirement. So that whatever the shaft we are going to design, so that should satisfy this requirement. So such parameters are called the functional requirements. So sometimes it may also involve the load transmission capacity and energy storing capacity. Suppose if I want to design the pressure vessels, so some cylinders, so in that case storage capacity will be important criteria, that is the functional requirement. Okay, so next parameter is material parameters. So material parameters means these are the properties of the material. So this FRPs and MPs both are independent of each other. Means this is not dependent on other two, that is geometrical parameters and material parameters. And material parameters also not depends on the functional requirement parameter and geometrical parameters. So next is geometrical parameters. Geometrical parameters means which these will define the shape and size of the whatever the design component or part. So these geometrical parameters are dependent on other two, that is material parameters and functional requirement parameters. Functional requirement parameters are again classified into two types. So desirable effect parameters and undesirable effect parameters. So desirable effect parameters means, So these are the parameters which have positive impact. Suppose let us say deflection of the spring. If you consider the example of deflection of the spring, if deflection of the spring increases, its load carrying capacity is going to increase. Means if you want to increase the load carrying capacity, so delta value should maximize. Means if you increase delta, it will increase load carrying capacity of the springs. So that means it will have the positive impact. So such parameters are called the desirable effect parameters. And undesirable effect parameters means, so which you want to reduce. Suppose let us say stress induced, so we should reduce it. Cost of the part, we should reduce it. Weight, we should reduce it. So these are the undesirable effect parameters. So this is functional requirement parameters we are going to classify into desirable effect parameters and undesirable effect parameters. So next we shall see, so which is already explained at starting, just what is meaning of design or adequate design or sufficient design and optimum design. So adequate design means it is designing object by selecting these parameters, geometrical parameters and material parameters in order to satisfy the functional requirement. So this is adequate design. Then what is meaning of optimum design? So designing the object by selecting the GPs and MPs, geometrical parameters and material parameters in order to satisfy the functional requirements by increasing the desirable effect parameters and by reducing the undesirable effect parameters. As compared to the adequate design in case of optimum design, so these things we need to consider. So next is optimization equation. Means how to optimize the things. So that is, optimization is done by forming the equations and classifying them into, so that is functional requirement parameters, material parameters and geometrical parameters. Okay. So optimization equation. So here one example, let us take one example, that is spring. Design the object to increase the load carrying capacity. So here optimization parameter is load carrying capacity. We need to increase the load carrying capacity of the spring. So what is this deflection of equation for the deflection of the spring? So this is the equation for the deflection of the spring, that is delta is equal to 8 into W into D cube into N divided by G d raised to 4, where delta is deflection, W is load carrying capacity, D is mean diameter of the spring, small d is wire size of the spring, G is modulus of rigidity, N is the number of turns. So if you rearrange this equation for load carrying capacity, W is equal to, so you will get this equation. So here we are going to classify, we are going to separate. So what is our main optimization parameter is to increase load carrying capacity, that is functional requirement parameter, that is W is equal to, what we need to do is we need to increase deflection so that W will go into increase, that is desirable one. So that's why it is a desirable effect parameter. Delta is desirable effect parameters. Next is geometrical parameter. So small d, capital D and N. So this will define the size and shape of the spring. So that's why, so this is geometrical parameter, and G, capital G is the modulus of rigidity, which is material property. So this is the comes under the material parameters. So like this, so we are going to classify the equation into different parameters. So next you take the example of the design of the design the object for cost reduction. Suppose if I want to reduce the cost, so here symbols used are unit cost, means it is per kg, it is C, and total cost is Cm. Okay, so total cost is given by unit cost into its total weight. Okay, so Cm is equal to, suppose if the cost is given per kg, then we can go for the C into M. C into M. M means it is rho into V. So instead of M here it is used is rho into V. So rho into V is volume. V means volume. It is volume is given by area into length. Okay. So here if you classify into this equation into three categories, that is functional, geometrical, and material. C is, that is cost. That is undesirable one, we need to reduce it. So that is undesirable effect parameter C. So area and length, they are geometrical parameters, and rho is density of material, which is material property. Okay, so next is types of parameters. So we are going to classify parameters into three types. That is, first one is specific parameter, that is specified parameter. Specific parameter. So what is meaning of specific parameter? Suppose here it is given P equal to 30 kilowatt. Suppose if I say I want to design the shaft which will transfer the power of 30 kilowatt, that is, here I am defining the power transmitting capacity specifically. Specifically I am defining exact value. Then such parameters are called the specific parameters. Suppose if I say shaft should transfer minimum power of 30 kilowatt. So here power is not specific. Minimum is 30, maximum may be any much. Okay, so that is, so if we define exactly, then it is comes under specific parameter. Suppose if you define with limits, suppose let us say shaft diameter should be less than or equal to 20 mm. It should be less, maybe 18, maybe 17, maybe 16, but it should not be more than 20. Here it is limit is given, not exact. Then it is called limited parameters. So stress is also comes under the limited parameters. That is allowable stress is equal to ultimate upon FOS. Okay, so and then parameters which doesn't come under these two, so they are called the unspecified and unlimited parameters. Next is types of equations. So equations we are going to classify into three types to make the optimization. First one is called the, suppose if I want to reduce the weight or cost reduction, if I want to weight or cost reduction. So if suppose let us say if weight in optimization, weight is decreasing, weight we also decrease, and cost also we have to decrease. So suppose if I want to reduce the weight or cost. Okay, so what is the primary design equation is? So first one is called the primary design equation. What is my main aim is to reduce the weight. So weight is given by Cm, total weight is given by C into M. Instead of M it is written, it is rho into A into L. So this equation, so we have seen in the previous slide. So next comes under secondary design equation. So this is also called the subsidiary design equation. So stress equations comes under this category, that is subsidiary design equation. Okay, stress is equal to P upon A. Next is limiting equation. So allowable stress should be less than or equal to ultimate upon FOS.